Imagine a computer that can learn like a human brain, recognizing patterns and making decisions with astonishing accuracy. The programming and logic that goes into such a computer is called deep learning. Let's get to know more about deep learning. So, it is a specialized subset of machine learning, which itself is a branch of artificial intelligence, AI. It focuses on using neural networks with multiple layers to analyze vast amounts of data, enabling machines to perform complex tasks such as image and speech recognition, natural language processing, and autonomous driving. The term deep refers to the number of layers in the neural network, which can range from a few to hundreds or even thousands. Now, how exactly does deep learning work? Deep learning models operate through a process that mimics human brain function. To understand this better, we need to understand about the neural networks. These consist of a set interconnected nodes, or neurons, organized into layers. The first layer is an input layer, which receives the raw data. Examples are images, text. Then comes the hidden layers. These layers perform computations and feature extraction. Each neuron in a layer is connected to all neurons in the previous layer, allowing for complex transformations and abstractions of the data. Then comes the output layer. This layer produces the final prediction or classification based on the processed information. Now let's talk about the training process. Deep learning models learn by adjusting weights and biases associated with each connection between neurons. The training process involves a few different parts. First is forward propagation. Data is passed through the network from input to output, generating predictions. Next is loss calculation, which is the difference between the predicted output and the actual output, ground truth, is calculated using a loss function. We also need to understand backpropagation, which is how the model adjusts its weights based on the error calculated, allowing it to improve over time. Finally, we need to understand activation functions, which determine whether a neuron should be activated or not, introducing non-linearity into the model. Common activation functions include ReLU, rectified linear unit, sigmoid, and softmax. Also, one important thing to keep in mind is data requirements, as deep learning models typically require large data sets to train effectively, as they need to learn intricate patterns that simpler models may not capture. Now let's walk through a step-by-step example of using deep learning for computer vision in processing U.S. residential mortgage documents. Suppose our business goal is extracting key information from mortgage documents, and we want to use deep learning to automatically extract key information, example borrower names, property addresses, from scanned images of mortgage documents. So here is the step-by-step process. Step 1. Data collection. To begin, we need a large dataset of scanned images of various mortgage documents, including loan applications, deeds, and titles. It's crucial that our dataset includes documents from different lenders, states, and formats to ensure our model is robust and adaptable. Step 2. Data annotation. Next, we manually annotate these documents to highlight key fields such as borrower names, property addresses, loan amounts, and dates. Tools like LabelImage or CVAT make this process more efficient. Step 3. Data pre-processing. We enhance image quality using techniques like binarization or noise removal. Then we normalize the images to a standard size and format for consistent processing. Step 4. Model selection and training. We choose a suitable deep learning architecture, such as convolutional neural networks, CNNs, for image feature extraction, or recurrent neural networks, RNNs, for sequential text analysis. We train the model using our annotated dataset. Step 5. Model training details. We split our dataset into training, validation, and testing sets. We select a suitable loss function and optimizer, and perform hyperparameter tuning to optimize model performance. Step 6. Model deployment. We integrate our trained model with optical character recognition, OCR, software to extract text from identified regions of interest. Then we develop an API to deploy the model, allowing it to process new documents and return extracted information. Step 7. Testing and validation. We evaluate the model's accuracy using our testing dataset and calculate metrics like precision, recall, and F1 score to assess performance. Step 8. Continuous improvement. We implement a feedback loop to collect user feedback and retrain the model periodically. We also continuously update our dataset with new document types and formats to maintain model accuracy. That concludes our overview of using deep learning for extracting key information from U.S. residential mortgage documents. By following these steps, you can create an efficient and accurate system for document analysis.